Okay, compare the gradients. Complete the tables of the value for 4 lines P, Q, R, S. P is this line, Q is this line, R is this line, S is this line. Okay. Okay, here we this picture. Let's do a frame. Okay, so let me just do for only maybe R and S. You can do the P and Q at home. So you'll get the idea if I do R and S, right?
Yes.
Okay, so R and S. So it's basically simple, the previous lesson, right? That we did. We just gonna put the value. Suppose I'm doing for the R now. So simply we're just gonna put the value of x one by one and we'll get the y. So here we put the x is equal to -2. If we put this one, how much will be the y? Y will be 3 times like -2
3
-2,
times.
that means -6.
Oh, you're on R.
Yeah, we on R and R, the first number, first value,
And
you can say.
you,
There are like
you,
5 values, right? -2, -1.
you said -6.
uh, Sorry, -6. Yes, -6 is the answer, right?
Yes.
Okay, similar thing, just do the rest one. I think you get the idea, right? So I'm just gonna do it a little bit faster. So if we put the -1, how much will it be? Minus
-1.
3.
Yeah, it'd be -3. And 3 is 0. 3 times 1 is 3. 3 times 2 is 6.
Yes, so the rest of 0, then 3, then 6, right? So this one is easy. Now let's do the next one, which is S, and the P and the Q will be the same process. Okay, you can take this as HW. Let's just do one more, like for S, what will be the answer? If it is -2, what will be the answer?
Mm.
-2.
-2.
If you put the value -2 here, then what is the value of YB? Suppose I'm doing just one for understanding. So half, if you put the -2 here at the x, we replace it with -2 now, because the x value is -2 here. So now we find the y for -2. So it will be something like -1, right? The
Yes.
-1. Okay, so similar thing, -1, if we put the -1 here, or -1, we get how much? -half, right?
Yes.
Similar thing, 0, 0, 1 means half, and 2 means 1. So that's how you put the value here. Okay, now let's go on with our next page, which is plot the labels line for PQRS. That means plot the line. Okay, so if you want to plot the graph, it's quite simple, because we can only plot for now RNS, because we have done the table, right? So we are just gonna plot the RNS. Okay, suppose we are now just plotting the R and the S. So
Hmm.
Okay, suppose we're now plotting the r. So how will you plot it? Same thing in the previous lesson that we learned. So what we will do, we'll put the x and y value. Okay, so -2 -6. Okay, the first we can understand the points. -2 -6, right? -1 -3, 0 comma 0. Then another point is 1 comma 3. Another point is 2 comma 6 for r, right? For
Yeah.
r. Okay, so let's put one by one. For this one we'll go -2, that means we're going on the negative side here, and -6 means downwards, that means here. That's the point, right? This is the point.
Yeah.
Similar thing, -1 -3, where is it? Here. This is the point.
Hmm.
Similarly 0 0, where is it? Here. 1 3, where? 1 and 3 here, right? 2 6, where?
Yeah.
2 6 is here, right? I mean, it's
Yeah.
like a line here, you can say. If you connect those dots, you'll get a straight line which is represented here, and this is the graph for r. That means y is equal to 3x, right?
Yes. Hmm.
So similar thing, we put the graph for s also. S is similar way. We're just gonna put minus, we can separate the points as similar as we did here, and put the graph, or sorry, draw the graphs. Can you do it at home? This is quite easy. Or can you do
Okay.
it now and show me? That would be a little bit work for you. So do it like in 2 minutes and show me what you got.
So like draw all of them.
Yeah, see 5 points. Yeah.
Okay. Yes, I can do that.
Do you have graph paper at your home?
Yes, I do have graph paper.
Okay, so that will be helpful for understanding. So use the graph paper, and if not, if you don't have any graph paper, you can draw reference line that we do in mathematics most of the time when we don't have a graph paper. We assume the points that it might be here.
I do have a couple of coordinates that I made previously. Can I use those?
What is it? Minus half.
Um, a coordinate like coordinate grid. Oh, I
Coordinate
found
grid.
one.
Okay, you can do it. You have separate graph paper, right? Like coordinate.
Yes, I do.
Okay.
Let me get a ruler. Also, sir, can you like expand your screen so I can see the writing?
Expand my screen means this way.
To like yeah, no, other way, other way. Oh, no, wait.
This table you need right now, right?
Wait,
S.
hold on.
You just need the S table because you're drawing the S table, right?
Drawn by the X. Complete the complete was the J. Did we already did
Yes.
can you like fully? Yes. So hold on. Okay. Yep. Now. Okay. Wait. Should I do all four or just one?
S. Oh, you should do only the S,
Okay.
right?
So only S. Yeah. Okay. Yep.
S. Y is equal to half X, right? Do this graph.
Yes. Okay. So -2. -2. -2. -1. -1 is 0.5. -0.5. 0 is 0. 1 is 1.5. And 2 is 1. Okay, so I shall send you. Okay, sir.
Okay, let's see the graph. Yeah, super. Right. -2 -2 -1. Yes. Half. Yes. 0 0. Yes. 1 half. Yes. And 2 1. Yes. Okay. And in graph paper, yeah, here you have discussed an important concept here, which we miss in normal graph here, which is that how many units should be counted as one, how many squares should we count 1 unit. In graph paper there's a concept that we can represent the amount of unit in the square. There's a concept here where we can take two squares and count as 1 unit, right? That is allowed in graph paper, because what happens here that we can draw any graph in a zoom position or a minimize position. That is allowed, or that is flexibility, or the advantage of graph paper. Do you understand what I'm trying to say?
Yes.
Okay, so here, what do you how many squares have you taken 1 unit?
I took 2.
Yeah, so here the concept is 2 square is 1 unit. Okay, 1 unit means one value or something. So for example, if we count here in both axes, this concept is applicable. That means in x-axis and y-axis also. So you took x-axis and y-axis the units. Okay, how
Okay.
many squares? 2 squares as 1 unit. So we can take 5 squares as 1 unit. Can you send me a full graph paper in your okay, don't worry, wait. Graph paper, I can show you another concept here. Suppose this, no, not this one. Yeah, let's take this picture here. Okay, free online, download PDF. You don't need the PDF. Okay, so here, see another concept here, that suppose this is the graph paper that we have in our home. Okay, now what's this? Suppose I can take like 3, depending on the, of course, value. What should we do with the squares? We should firstly observe the value in our table, because in our table it will be clear that how many squares we should take how many units with. This table will answer you. if the table's value is like more fraction, that means suppose there are like 2.5 in the value, or like 2.3 in the we can say in the table, or like maybe 2.6, maybe like 3.2. So depending on the situation, we can take even 5 squares as one unit also. That means that if this point is 0 0, 1
Hmm.
2 3 4 5, see, that means this is one unit. Even we can take on right side, left side, even downwards, 5 units also. So 1 2 3 4 5, this one. Similarly on down, 1 2 3 4 5, this one. Minus 1, 1 2 3 4 5, minus 1. So depending on the situation, we can take or flexible, we have flexibility in the square area, that how many squares should be count as one unit, that we have advantage. So even 1 2 3 4 5, the next unit comes after 5 squares. 1 2 3 4 5, 2, 1 2 3 4 5, this one, 2, 1 2 3 4 5, this one. So now if we plot this same graph, suppose we want to plot this graph here, right? So now we'll
Yeah.
see that the values, because we have taken more squares as one unit. Now how much? 5 squares is like one unit, right?
Yes.
So now the figure will be more bigger. The figure will be more bigger than this one, because what you're doing in this concept here, you're zooming into the figure. That means you're zooming this, and this will convert a large portion of this figure on the right side. If you plot it, you'll see the difference quite easily. Suppose I'm plotting it like minus 1, okay, minus 2, minus 1, let's take it. Minus 2, minus 1, minus 2, minus 1 here, this one. Now we take the next points, 1, minus 1, and minus half. Okay, minus 1 and minus half is somewhere in between this. Okay, this, then 0 0 is of course in the middle. Then we take the 1 half. Okay, 1 half, 1 half means in the middle, of course, here. Then the next point is 2 1. Okay, 2 1, this one. Okay, now if we connect them, or maybe take a straight line for reference. Okay, okay, okay. Now the graph is something like this one. It's the same graph as you draw in this picture right here. Same graph, no difference. But what happens here is that we get a more zoom version of the graph, right?
Yes.
So same thing, but if you change, if you take more square in one unit, that means you're drawing it a little bit bigger. Okay, now let's go to the next slide. Okay, same thing, JKLM, 4 tables are given. You need to maybe complete the table and plot the graph. Same thing, right? Nothing different. Same
Yes.
type of math, right? You can do it at home, right? There's
Hmm.
no new thing learning here. We're doing the same thing again. Okay, now plot the graph, same thing. Okay, Okay, now compare your answer to question 1 and 2. What is the same and what is the different? Okay, firstly we have to complete the answers, otherwise we cannot say what's the same and what's the different, right? So you have to complete it, then comes the observation. Okay, firstly complete it and show it to me tomorrow. I'll then discuss this question. Okay.
Yes.
Okay, so take this slide as HW. Okay, this one, complete J K L M. You can do it easily, I think. Not need to show. Should I show any of them?
Okay, yes.
Which one? Then I'll show only one. Which one?
Wait, hold on, sir. Can you show the -3?
-3 L.
Yes.
Okay, I will take this figure here. Okay, so let us complete this. Let's complete this. Okay, L L. So what should be if a -2 comes? Similarly, we can draw the equation or take the equation and get our answer. Suppose y is equal to -3x. We put one value here, that means -2. Minus minus or negative negative is positive, and we get 6. That means +6. Similar thing, that -3 in times -1 is like negative negative. We get positive 3. If we put a 0 here, we'll get also a 0. Nothing to calculate. If you put 1, that means -3. If you put 2, that means -6. So that's the table for our L, or y is equal to -3x. Now we just gonna plot the graph in our paper. We take the graph paper and plot it. Okay, you understand the table, right? Do you have any question on the table?
No, sir.
Okay, so we're just gonna plot it. Okay, if you plot the points, so firstly you can take or write down the points in the side for helping, or you can just put it from the table as you wish. So -2 6. Okay, let's take -2 and 6. -2 comma 6. Okay, where is it? -2 here, 6 is upward, of course, positive value. That means up. This means here. Now comes -1 and 3. -1 comma 3. Okay, where is it? -1 is here and 3 is here. Okay, so next comes 0 0. 0 0 is here, nothing to calculate. That means 1 minus 3. Okay, 1 is here, -3 is downwards here. Then comes 2 minus 6, that means here. Okay, so 0 0, 1 comma -3, and 2 comma -6. Okay, now if we connect those lines, we'll get our straight line. So it's a straight line, we'll get something like this, right?
Yeah.
So this is the graph for our points, and you can also draw the points here if you want to, like minus 2 sorry, minus 2 comma 6. This point is minus 1 comma 3. This point is 0 0. This point is 1 comma minus 3. This point is like 2 comma minus 6. So you can also take the or draw the points on the graph or coordinates on the graph. Okay, that is also allowed in the graph paper. And you can also, for reference, name the points, like this one is A point, this one is B point, this one is C point, this one is D point, this one is E points. So A, B, C, D, E, you can call it the coordinates like this name. That's also allowed.
Thank you.
Okay, next question. Okay, 5 lines are given by the followings. Okay, there are 5 lines here: L1, L1, L2, L3, L4, L5. What is the same about that equation, about the equation, or what is the difference? Okay, what's the same and what's the difference? So what's the same in this 3 or 5 equations? Sorry, 5 equation. What's the same here? What's the same and what's the difference? Can you answer?
Wait, where? Where, sir?
Here, in the slide here. This is the question.
The 5 lines are given by the following equations. What is the same about the equations? What is different?
Yes.
They all have an L. What is the L for?
Hell is just a name, or we can say is just
Oh,
a
lines. Lines.
line or symbol, nothing else. What should be the answer? Let's see what is here. All lines pass through the origin. Same is that all lines pass through the origin. Different is that positive variance only in question 1 and negative variance in question 2. Is it? Oh, sorry, 4 number. Each of the equation have 3 as a coefficient of x. Okay. Difference is that their y intercepts. Their y intercepts. Okay. Yes. Do you understand their what they're saying in the 4 number question?
Not really, sir. Can you explain it?
Okay. Firstly, take this equation. Okay. What do
Okay.
you see in common? Do you understand the coefficient, right? What's the coefficient? Do you understand what's the coefficient?
No, what's the coefficient?
Coefficient is basically you have to understand variable first. Do you know what's variable?
Yes, I do, sort of, yes.
So what's the definition of variable?
I don't know, sir.
Okay. So variable is the basically the you can say algebraic term, or we can say algebraic alphabets in easy way, that the values changes. Value is changeable. That means value changes, and they are basically in algebra. The variables are defined or symbolized by x, y, and z. These 3 type of situation we can say variable.
Okay.
The variable, simply we're gonna say that value is not fixed. That means value is changeable. Value is not fixed or changeable. Not fixed. The value is changeable, or we can say the value can change. Okay, that means why we say that this is a variable, because if we take any equation here, suppose I'm taking L1 for now. Okay, y is equal to 3x, this equation, right? So where is the variable here? How many variables are in this equation?
Um, the value is not. Is it x?
X, yes, x is a variable. And is there any
Y.
other? Y, yes, there are two variables here, right? Why they are called variable? X and y, why are they called variable? Because you can put any value of the x here, right? That is all allowed. And for that value you get it every time, you get a different value for y, right? Suppose you put x is equal to 1, what will you get for y? 3, right?
Hmm.
If you put x is equal to 2, what will you get? 6, right? Right.
Yes.
So here you can say that x value is not fixed, right? You can put any x
Hmm.
value. Similarly, for putting the x value, we always get a different value for y, right?
Yes.
So that's why these two are called variable, because their value is not fixed. We can put anything here. So that's why they are called variable. Now comes the part coefficient. Coefficient is basically, we can say, the value is fixed. Coefficient is the opposite of variable. Okay,
Okay.
coefficient is what the value, we can say value is fixed. That means any numbers, 2, 3, 4, all are coefficient. Anything, any numbers, because any number is a fixed value, right? 2 is
Hmm.
a fixed value. 2 means what? 2, nothing else, right?
Yes.
So 2 is a fixed value. So here 3 is a coefficient in this equation, y is equal to 3x. Do you understand now where is the coefficient?
Hmm. Yes, I do understand.
This is the coefficient, this one is a coefficient. And coefficient, another thing that yeah, it's a fixed value, uh, variable. And just a minute, wait a minute.
Hmm.
Okay. And another thing that a coefficient is always multiplied with an variable. Do you understand?
Yes.
Coefficient is always multiplied with a variable. Suppose 3 is multiplied with x, right? And x is a variable, right? So
Hmm.
coefficient is always multiplied with a variable. That means here the coefficient is 3, right?
Yes.
Here 1 is a fixed value or a number, but we cannot call it a coefficient because it's not multiplied with a variable. Two things you should remember in case of coefficient. Number one, fixed value, of course, right?
Yes.
and
Hmm.
number 2 is that it should be multiplied with a variable. Multiplied with a variable, it should stay, or in equation it should stay uh, multiply with variable, this thing. Okay, so here 3 is a coefficient, right? 3 is a coefficient here, and 3 is a coefficient here, right?
Yes.
Okay, now the same thing is that they all have coefficient 3, nothing different here, right?
Hmm.
And what's the difference?
Pardon, sir?
And what's the difference here? So what's the difference here? From answer sheet we can say that they say the difference is that the intercepts y intercepts where? What's the y-intercepts here? What is the
It,
y-intercepts?
it intercepts 1.
Yeah, uh, y-intercept means that the equation, if we compare it to y is equal to mx plus c, with this equation, this is the standard equation for a straight line, or we can say this is the equation for straight line. Basically this is the mother equation for straight line. So in this equation, this c here is the y-intercepts. Y-intercepts, what does it mean? It means that if we draw or plot any of this equation, then it will show how much y it has cut off, or the graph, how many uh, how many values it cut off. For example, if you plot any of these graphs, suppose I'm taking the 2 number now, L2, which is 2 plus 3x. Okay, 2 plus 3x, right?
Yeah.
And now if we just a little bit sequence, or just left right, right? Okay, front back, we just arrange this equation, and now we compare it to the main equation, y is equal to mx plus c. So here we can easily say that y-intercepts is 2, right? This portion right
Yes.
here, and not just
Hmm.
2, plus 2. Of course, be careful. Y-intercepts plus 2, right?
Yes.
So if you compare this here, and now that means what does it mean? It means that if we plot this graph in our graph paper here, suppose I'm taking a graph paper by hand, freehand, that means that in the 2, that means positive direction of y-axis plus 2, here the graph will be something like this way.
Okay.
What it shows here, that from 0, that means this position here, how much square, or how much unit it cut off from y-axis. So it will cut off 2. That's why reason that y-intercept means that y has been cut off in the equation, or y portion, or in the y-axis it has been cut off how much, the value represent that.
Okay. All right.
Okay, suppose now you have a equation something like let's say um, y is equal to 3x, and then you got minus 6. Now how will you draw this? in the equation, or where the y-axis will be cut, you can say y-intercepts.
The y will intercept -6.
Yeah, that means we have to follow the -6 right here, right? Suppose somewhere in the
Yeah.
downwards, right? And if we
Hmm.
plot the graph, we'll see that it will go through here, right? It will be something like this, because this intercepts gives us the an idea how the graph will be. It will be something like -6 has been cut in the negative side, and the graph plotting will be something like this if we put the values or form a table as we wish, right? So it will be something like this.
Yes.
Okay, so uh, any other question?
No, sir.
Okay, so should we continue any further?
I understand everything.
Okay, so we'll do the rest of the sequence on our next class. Okay, let me continue with your brother now.
Okay, yes. Thank you very much, sir.
Okay, thank you very
Thank you
much.
so much.
Welcome.